Today we will discuss about unguided media, that is wireless media. Okay, we have studied already the guided media. So we knew that guided media can provide us much more protections over signal. When a signal is passing through the channel, then the channel there is different types of noise can affect the signals. So if we have guided media, and there are different types of guided media we have studied, so different categories of guided medias are there. So according to the different types of protections, the guided the signals are guided inside the wire. Okay, but here we are talking about unguided media, that means the media is wireless. Okay, so nothing is actually there is no protections actually. So that is the space is the unguided media. So we have a space is the unguided media. Okay, so unguided media transport electromagnetic waves without using any physical conductor. We don't have any physical conductor. This type of communications is often referred to as wireless communications. So here we will discuss about radio waves, microwaves, infrared, different types of waves are there. Okay, so so this is the electromagnetic spectrum for wireless communication. So here you can see that this is the radio wave and microwave, and it can pass 3 kilohertz to 300 gigahertz. Okay, this is the range. Radio wave and microwave, they can pass, the waves is their wave contain 3 kilohertz to 300 gigahertz. Okay, and infrared rays, it will accept 300 gigahertz to 400 terahertz. Okay, and this is the light wave, this is 400 terahertz to 900 terahertz. So this is the spectrum for wireless communication. So now this is the propagation methods. So we have these are the propagations method. Here you can see this is the ionosphere and this is our earth. So this is the ground propagations. So this is below 2 megahertz, and here this antenna, the positions of antenna, you can see that these are the antennas. Okay, so here is the antenna, this is our antenna, this is putting here. So this is ground propagations, it is below 2 megahertz, and this is sky propagation. So you can see these two antennas are putting in such a way that there is a sky propagations, the signals is reflected here, the ionosphere, and it can goes to the another antenna. And that means when we are talking about free space, that means we need a device which can pass the signal, which can accept the signal. Okay, so what are those devices? That is our antenna. Okay, so these are the antennas, and this is the line of sight propagations. This is above 30 megahertz. The signal can contain above 30 megahertz. So this is the line of sight propagations. The line of sight propagations means what? There is no reflections. The antennas are provided in such a way that they can straightway they can pass the signal from one to one. They can in the same line. Okay, so that is the line of sight. They are in the same line. So this is the line of sight propagation. And these are the different types of frequencies, and that is different type of frequencies what an antenna can accept, what we can transmit via this free space. And there are different ranges are there, and propagations, some propagations are ground propagations, some are sky and line of sight. Okay, and applications, what types of signals is getting these type of things. So you do not know in details about these all things. Now this is the wireless transmissions. So wireless transmissions can be happen. There are three different types of waves, that is radio waves, we have radio waves, microwaves and infrared. Okay, radio waves, microwave, and number 3 is infrared. So different types of waves we can transmit. So radio waves are what? Radio waves are used for multicast communication. So what do you mean by multicast communications? Multicasting and unicasting. So we have different term, that is unicast. Unicast means when a device is sending to another single device, that is unicast, one to one. When a sender is sending informations to a particular receiver, and that receiver can send any informations to this particular receiver. So this is unicasting. And if I am saying multicasting, that means a single devices are here and it can transmit the data to this PC, and there it can transmit the data to another PC also. So multiple devices, they can pass the data to the multiple devices. Okay, so this is multicasting. So radio waves are used for multicast communications. So if we want to send our informations more than one devices, then we need we can use radio waves, and such as radio and televisions and paging systems. So radio waves is for radio, televisions, different paging system, and they can penetrate through walls. Okay, the signal can pass through walls. If your rooms are closed and windows and doors, everything is closed, then also the signal can come to our radio or TVs, televisions. Okay, the signal we can get. So radio waves can penetrate through walls. Remember it. It can penetrate through wall. This is highly regulated. We can regulate it and use omnidirectional antennas, because it can, when this signals is accepted by a omnidirectional antenna. Omnidirectional means the antenna which can pass the signal in all the directions. This is the omnidirectional antenna. Here you can see this is the range. This is the overall. This is the width of signal transmissions. That means the all sides of this antenna the signals can pass. So obviously for radio and TV we need this type of signal. That means the signal must be passed to each and everywhere throughout the signal. Okay, so for radio wave we need omnidirectional antenna. So this is about radio waves. So first point you have to remember that this is a multicast communications. Number 1, multicasting is going on here, and the examples radio waves can we can get the radio waves in radio, TV and different paging systems, and they can penetrate through walls. Okay, it can penetrate through walls. It is highly regulated. You can regulate the signal. The signal you can control. It is highly regulated, and for this type of signals we need a omnidirectional antennas. Okay, so now we have microwaves. Microwaves is what? Microwaves are used for unicast communications. See, this is for unicast communications. Unicast communications such as cellular telephones, satellite networks. These are such as cellular telephones, satellite networks and wireless LANs. These are the microwave connections. So higher frequency ranges cannot penetrate walls. So the frequency is high, so it cannot penetrate walls. So that is the difference. So there can be a questions that what is the difference between radio wave, microwave and infrared. So for microwave you can use unicast communications, but radio waves we are using multicast communication. Okay, and you can use the examples also for difference. That is examples of radio waves, that is the it can use for television, radio, paging system, but here this will be used for cellular telephones, satellite networks and wireless LANs. And higher frequency ranges, the frequency is high. Here the frequency is high, but the radio frequency is low. But this microwave, the frequency range of microwave is high, so it can't penetrate walls. Okay, it can't penetrate walls. If everything is closed, the signals you can get. It can use what type of antenna? It can use directional antenna. Okay, directional antenna, that is point to point line of sight communications. Directions, we need a directional antennas. Okay, so this is point to point connections like this. This is antenna and this is antenna. So this is a point to point. That means they must be in a straight line. If the lines are not straight, then if suppose this antenna is not directly send the signal to the another antenna, the positioning is not in the same line, so the antennas cannot get this type of waves. So here we have to use directional antenna, and the connections is point to point, and this is line of sight communications. Okay, just point out these points. So these are the features for microwaves. So here what type of antennas we can use? That is directional antenna. Okay, so these are the directional antenna. So here we have dish antenna and horn antenna. Okay, so dish antenna and horn antenna we have, and this is the focus. This is the focus line. So the signals can pass through this antenna, and the signal can provide to a particular location. Okay, this is the focus, so it can pass through a particular location. It can pass through a particular location. So this is a dish antenna, and this is another antenna. This is a horn antenna. Okay, so horn antenna, here this type of antenna you can use for microwave communications. So for this horn antenna, we just provide the signal in this way. The signal comes here, and it can go in a single directions. Okay, here also we can see in this antenna we have this type of signals also, and they can provide to a particular if there is a focus, they can provide to a particular location. And here also in horn antenna, this is also a unidirectional antenna, that the signal can pass through a single directions. So this is the wave guide, the signal is passing through this antenna, and it can provide to a particular locations. Okay, particular direction. So this type of antennas we can use for microwave communications. Okay, so this horn antenna, what you can see, it is like a gigantic scoop. Okay, and the outgoing transmissions are broadcast of a steam, and it can be deflected outwards. See, this is the deflections outward, and you can have the series of parallel lines. Okay, when this signals is reflected here, it can deflected outwards, and there is a series of narrow parallel beams. Okay, single directions. So this is the horn antenna. It is a unidirectional antenna. These are the examples of unidirectional antennas are dish antenna and horn antenna, which we can use for microwave communications. And microwave communications, you should remember, this wave cannot penetrate one wall. It can penetrate a wall. Okay, so now we have for our third signal, that is infrared signals. So infrared signal is what? Infrared signals can be used for short range communications. Okay, so this infrared signals can be used for short range communications in a closed area using line of sight propagations. Here also you can see that this is also for line of sight propagations. That means the signal must be the antennas must be in the same line. So and it can travel short range. This is a short range communications, is the closest area. Okay. So infrared channel, this is for very short distance. This is short range. This is the short range communications, and that means this type of signals we can use in our nearest area, closest area, not far distance, and there is a line of sight propagations. So now there are some points about wireless channels. What type of channels we have? Wireless channels means what is the different criteria this type of channels have. So these channels are wireless, that means there is nowhere, so this is a free space, so we can't guide our media, the media is open. So these channels are subject to a lot more errors, okay, than guided media channels. It's subject to lot more, it have a lot more errors than guided media channels, and infrared is one of the infrared is one cause for errors. It can be circumvented with high SNR. So signal to noise ratio should be high. Excellent. তোমরা দাঁড়াও এক সেকেন্ড, অ্যাটেন্ডেন্সটা দাও তো। তারা প্রেজেন্ট করছে, অ্যাটেন্ডেন্সটা দিয়ে দাও। ফর্মটা দিচ্ছি, দাঁড়াও। এর মধ্যে পাচ্ছিস না জামাটা? জামাটা দেখ, এর মধ্যে নেই আমাদের ঘরে। জামা কোথায়? আর একটা জামা আছে তো, দুটো জামা তো, আর একটা জামা আছে, এটা সেটা আমাকে খুঁজে দিতে হবে। টাওয়ালের মুছো না, আমাদের ঘরে টাওয়াল আছে, যাও। তোমার গামছা তো বাথরুমে, তুমি তো জানো। আর টেবিলের ওই এতে একটু জল দিয়ে কর্নফ্লেক্সটা খেয়ে না। কেন ফেলো, কিছু হবে না, কিচ্ছু হবে না, কিছু হবে না। মোছা হয়নি তো কী হয়েছে, মোছা হয়নি তো কী হয়েছে, আমি তো হাঁটছি। অ্যাটেন্ডেন্সটা দাও সবাই। খেয়ে নিবি? নাম দিয়ে দিয়েছি। আচ্ছা ঠিক আছে, দেওয়া গেছে তো সবার? ওকে, চলো স্ক্রিন প্রেজেন্ট করি। কতজন এসছে আজকে? দাঁড়াও, So in the wireless channel, this is more we face much more error, because the media is the wireless channels are subject to a lot more errors than guided media, because in the guided media we can protect our signal, because the signal can pass through a shielded wire. Okay, so the wire is not exposed to the means outside circumference. So here everything is open, the space is our medium, so we can face, the signal can face lots of means error, noise can hamper the signal. So this is the first thing, it have lot more errors. Then that means you should know what is the difference between guided media and unguided media. Okay, so this is the first point. Second point is interference is one cause for errors. So interferences is here, this is one cause for errors, and it can be circumvented with high SNR. So high signal to noise ratio is here, so high SNR is here, and the higher the SNR, the less capacity. If the SNR is higher the SNR, higher the signal to noise ratio, the less capacity is available for transmission due to the broadcast nature of the channel. So SNR means what? SNR, that is signal to noise ratio. Okay, so that means what is the noise, what is the noise, that what is the value of signal and what is the value of noise. So obviously when you are passing a signal, noise must be there, noise must be hamper your system, but if it is but the ratio need to must be maintained, the ratio should be maintained. Otherwise, if noise is much more than the signal, then what will happen? Then the signal can be distorted distorted very badly. Okay, then we cannot get the proper informations through the signal. Signal should be corrupted by noise. So this SNR, the signal to noise ratio, should be maintained, it must be maintained. So the higher the SNR, the less capacity. If SNR is very high, then capacity is very low. So the transmission due to the broadcast nature of the channel should be very low. Okay, so channel also subject to fading and no coverage holes. So there is fading. Fading means what? What is fading? Fading means the loss of signals. Okay, signal can be lost when the signals is passing through the channel. The signal can be lost. So this wireless channel is subject to fading and no coverage holes. There is means you cannot have that. That means there is no coverage. Coverage in the sense that no coverage holes. That means maybe sometimes the signals is much more affected by the noise. Then you cannot assure that these signals can pass. These signals can can transmit this suppose 500 kilometer or 300 kilometer. So the coverage we cannot say that this is the coverage of the signals, because there are some, the noise can badly affect on that signal and the signal can be lost also. Okay, so this is the signal, this is the main thing for wireless channel. So these are the main points. What are the different types of problem you can face through this noiseless channel, through this wireless channel. Okay, so practically we can have different types of channels also. That is we only have noiseless channels, but if we have noise less channel, then it will be very much better. Then the signal cannot be distorted, it cannot be erroneous. Okay, but practically noiseless channel is not possible for us to get. We will get only the noisy channels. So these are the